Now, 1 second here.
Yes, it will be connected, I think. Yes, you are in.
Okay, sir.
Yes. Yes, in the last class, we were seeing that properties of carbonyl compounds, which means up to the reduction. Wolf is the reduction, Clemens a reduction, followed by reduction to phenols. Up to that we were discussed. And in this particular session, we have to talk about the haloform reaction. What is called haloform reaction? Haloform reaction is an important reaction. There is a condition for a compound to undergo such kind of reaction. The condition is the carbonyl compound should contain CH3C double bond O group in it. Otherwise, the compound should form CH3C double bond O during the action. Here, acetaldehyde and acetone are originally containing CH3C double bond O in them, and hence both the compounds can answer for this haloform reaction. Generally, haloform, specifically it can be called as iodoform when we use iodine as a reagent, and bromoform when we use bromine as reagent, chloroform when we use chlorine as reagent. Generally, haloform. The condition, I can say that the compound should contain CH3C double bond O in it. All your compounds containing CH3C double bond O can answer for this. This reaction is not new to you. Already the same is given in hydroxy compounds, which means hydroxy derivatives. For example, ethanol, CH3CH2OH, during its oxidation, it can able to form CH3CH4, and hence ethanol is answering for haloform reaction. Apart from the aldehydes and carbonyl compound, ethanol is an alcohol. It can able to produce CH3C double bond O during its oxidation, and hence it can answer for haloform reaction. Now the haloform reaction can be explained as follows. Just wait for a second. Hello? Wait a second. I think it's getting buffering actually. It will be all right. It's the haloform reaction in which we can take a compound called acetaldehyde, CH3CH4. This is the compound containing CH3C double bond O in it, so that it can answer for haloform reaction. All your compounds containing CH3C double bond O, including acetaldehyde, and even we can take acetone. This is the formula for acetone. It can answer for this haloform reaction. Actually, the Haloform reaction can be explained as follows for acetone: CH3C double bond O CH3 on chlorination in presence of sodium hydroxide. The first step in which all the three alpha hydrogen atoms can be replaced by the three chlorine atoms in this manner. The substitution takes place. At the end of that, we can have CCl3C double bond O CH3. This compound is said to be trichloroacetone. After getting the trichloroacetone, now it is to be oxidized. For that purpose, we are using the sodium hydroxide, NaOH. For the convenience, we can able to write like this, HONA. It is for the understanding purpose. So one of the compound is chloroform, and other will be the sodium salt of the carboxylic acid. It is called as sodium acetate. So we can have two different products like this. One is the chloroform, and other one is sodium acetate. And this is the action called as haloform reaction, easy to follow. So in the first step, all these three hydrogen atoms are combined with chlorine to form HCl. In the subsequent stage, trichloroacetone, it is to be treated with sodium hydroxide. While treating it with sodium hydroxide, one of the compound is chloroform. Other will be the sodium salt, called sodium acetate. And this reaction is commonly called as haloform reaction. Now the other topic would be Aldol condensation. What is called Aldol condensation? Aldol condensation reaction is explained as follows. Here also there is a condition. The compound which is containing with alpha hydrogen can undergo this reaction. So all your aldehydes and ketones containing alpha hydrogen atom in them can undergo this reaction. So this is the substance, we can say CH3CHO. The compound's name is acetaldehyde. It should be treated with sodium hydroxide in the first step. Conveniently, one of the alpha hydrogen is taken out of this. So I can write it as HCH2CHO on reaction with sodium hydroxide. The OH will take up this hydrogen. So it is called as alpha hydrogen removal, also known as alpha hydrogen abstraction. Once the hydrogen is leaving as H plus, the bonded electrons are moving towards this carbon atom, so that we can have a carbanion. This is the carbanion word. The carbon ion formed here can behave like a nucleophile. So the first step is over. We are getting nucleophile like this. The nucleophile obtained on further reaction with acetaldehyde. Yes, now I am writing the first molecule of acetaldehyde. So the explanation of that is CH3 C double bond OH. The second molecule of acetaldehyde is taken. That should be treated with carbon ion formed so far. This is the carbon ion formed. CH2CH4. It carries minus. So as usually this is behaving like nucleophile. It can attack this carbon and the nearby bond is getting broken. So this is step number 2. First step is the formation of carbon ion. Step 2, attack of carbon ion on the acetaldehyde. Due to this attack, we can have a product as follows: CH3CH, and it becomes O minus and CH2CH4. Still, it is having a charge. Oxygen is carrying minus. Now, it is to be protonated in the third step. The oxide formed above can be protonated as follows in step 3. Take CH3, CH, O minus and CH2CH4. This on protonation by using water, the electrons are given to this hydrogen, and the product will be CH3CH, OH, and CH2CH4. The compound formed here is generally called aldol. How to write its IUPAC name? The compound's IUPAC name can be given as follows. The number of carbon in the longest linear chain, 4 carbons are there. So it is to be called butanol. There is a hydroxy group at third position, and the compound's name will be 3-hydroxybutanol. So aldol is also called as 3-hydroxybutanol. These are the 3 steps involved in the aldol condensation reaction. In the first step, I repeat, we should take a hydrogen outside. The hydrogen which is noted here is alpha hydrogen. This is the hydrogen, alpha hydrogen. This hydrogen is abstracted. Due to that, a carbon ion is formed. This is the carbon ion formed. After the formation of carbon ion, that carbon ion should attack the first molecule of acetaldehyde. We are given the formula for acetaldehyde here. Yes, CH3C double bond OH. The first molecule that would be attacked. This is the compound acetaldehyde. Just follow the arrow mark. It is attacking on the carbon and the nearby bond is getting broken. So we can have an intermediate as follows. The oxide. It is to be protonated. The oxygen minus, O minus, which gives electron to this hydrogen. So proton is added with that, so that we will be having a compound called as aldol. This is a compound called aldol, in which it is the IUPAC name. 4 carbons are totally present, butanol. The hydroxy group is at third position, thus it is called 3-hydroxybutanol. And the 3-hydroxybutanol present on the previous step, on heating, this compound is not stable to heat. On heating, what is happening? Yes, if you heat it, I can write that reaction CH3 CH OH CH2, CH4. CH2, CH4, in which one of the hydrogen is taken outside conveniently. This compound on heating, there is a removal of water, dehydration takes place. You know what is called dehydration? This is the step called as dehydration step. There will be a beta elimination reaction, and that can be followed as follows. The hydrogen from this carbon is removed, and simultaneously OH is leaving. As a result of that, we will be having CH3CH, double bond CH, single bond CHO. This compound, CH3, CH, double bond CH, single bond CHO, is commonly called as protonaldehyde. The IUPAC name of this protonaldehyde, to count and find the number of carbon in the longest linear chain 4. So the root word must be but, where the second position is having the double bond. So 2-butene yal aldehyde, but2-ene-al. But2-ene-al is the IUPAC name of the protonaldehyde. So in this way, aldol condensation can be explained. And when you have the mixture of formaldehyde and acetaldehyde, that particular aldol condensation can be called as crossed aldol condensation. I'll explain what is called crossed aldol condensation reaction. This is the reaction called crossed aldol condensation reaction. Take a molecule of formaldehyde and acetaldehyde. Formaldehyde is not containing alpha hydrogen, no alpha hydrogen, but acetaldehyde is having alpha hydrogen, so it can undergo this reaction. But formaldehyde is not having, even when the reaction is possible. For the formation of carbanion, we should have minimum one alpha hydrogen. So we are starting from the acetaldehyde. Conveniently, one of the hydrogen is taken outside. The reagent in the aldol condensation is sodium hydroxide. The OH minus, which is provided by the sodium hydroxide, can take up this hydrogen to form H2O. So the bonded electrons are taken by this carbon, and we will be having CH2CHO, which carries minus. So this is the ion called as carbanion. So when you get the carbanion, in the forthcoming step, the carbanion can attack the formaldehyde. Yes, I am writing the formaldehyde, HC double bond OH. We know that oxygen is electronegative, it carries light minus, and the carbon is electropositive. The carbanion obtained in the previous step will be attacking this carbon, and the nearby bond is breaking. Nucleophilic attack, and the bond is opened, so that we can have a substance as follows: O minus and CH2, CHO. The compounds so far obtained can be protonated by using the water. That is as usual. Yes, I am writing that step HCH, O minus and CH2, CHO. It can be protonated by using water, HOH. O minus contributes electron to this hydrogen. Protonation takes place. Due to that, it is the result. We will be having CH2, CHO. Aldol type product. How to write the IUPAC name of this aldol type compound? Find out the number of carbon atom in the longest linear chain. 1, 2, 3. 3 means the longest linear chain shows that the parental hydrocarbon, the root word is pro, so that you can call it as propanol, as it is containing aldehyde function. Third carbon is having a hydroxy group, and the compound's name will be 3-hydroxypropanol. That's IUPAC name of this particular compound. And one more type of cross-aldol condensation can be explained by taking the formaldehyde and acetone. Yes, we are going to take the formaldehyde. It's a formula for formaldehyde HC double bond OH. There is no alpha hydrogen, but when you take acetone, CH3C double bond OCH3, it is going to have 3 alpha hydrogens. So it can undergo this reaction. If I am writing the acetone as follows, CH2C double bond OCH3, one of the hydrogen is taken outside and it is to be highlighted, and that should be treated with the dilute NaOH. While treating this with dilute NaOH, what may happen? The OH minus will take up this hydrogen to form H2. So the electron pair is moving towards the carbon. That results to the formation of a carbanion. This is the carbanion merge. As usually the carbanion formed here can behave like a nucleophile. In the next stage, this carbanion should attack the formaldehyde, HC double bond OH, and CH2C double bond OCH3. It carries minus. It is attacking the carbon and the nearby bond is open. So the product will be HCH and O minus, and we can have CH2C double bond OCH3. Now this is to be protonated as usually. On protonation of this, with the help of water, the product is obtained as follows. I can write HCH O minus CH2C double bond OCH3. On treatment with the water, HOH, protonation takes place. Due to that, this is the compound, and it becomes OH, CH2C double bond OCH3. Count and find the number of carbon atoms in the longest linear chain. 1, 2, 3, 4. 4 are there in the linear chain. So the root word must be the butane, but. As it is having the ketonic group, we can call it as butane 2-one, the ketone, butanone 2-one. The hydroxy group is present at the 4th position. So you can call it as 4-hydroxy butanone. That's a IUPAC name of this compound. Very simple to follow. So we have seen one of the simple aldol condensation and 2 crossed aldol condensation reactions are so far explained. Likewise, some of the important reactions of aromatic aldehyde called benzaldehyde. Yes, we can discuss the properties of benzaldehyde. The properties of benzaldehyde, and it is a formula for benzaldehyde, C6H5CHO. And it undergoes an important named reaction called Glycine-Smith reaction. What is called Glycine reaction, also known as Glycine-Smith reaction? And it is to be explained as follows. I can write C6H5CHO plus the acetaldehyde HCH2CHO. One of the alpha hydrogen is taken outside. The reaction takes place in presence of NaOH. So there will be the removal of water, which means I am writing 2 hydrogen outside. Only 1 H is remaining here. 2 of the hydrogens are taken outside. So the product is C6H5 CH double bond CH single bond CH4. Alpha carbon and beta carbon are having unsaturation. Thus, it is alpha beta unsaturated aldehyde. This alpha beta unsaturated aldehyde is nothing but cinnamaldehyde. Cinnamaldehyde is formed. And how to explain the mechanism of this Glycine-Smith reaction? For easy understanding purpose, it looks like the Aldol condensation. Yes, I am starting with the acetaldehyde. One of the alpha hydrogen is taken outside in presence of sodium hydroxide. The OH minus will take up the hydrogen to form H2O. So the carbon ion is formed as usually. It is the carbon ion. After getting the carbon ion, in the next stage, the benzaldehyde will be attacked by this carbonate or the carbon ion. It's a formula for benzaldehyde, and we are writing CH2CH4. It carries minus. The benzaldehyde is very well attacked. C6H5 C double bond OH. Benzaldehyde. It will be attacked by this carbonide or the carbon ion. The nearby bond is breaking up. So we can have C6H5 CH, it becomes O minus and CH2CH4. Looks like our Aldol type condensation reaction. In the very next stage, it should be protonated by using hydrogen plus. While protonation, what is happening? C6H5 CHO minus CH2CH4 on treatment with the water HOH. It gives electron to this hydrogen so that we can have C6H5CHOH, and I am writing one of the hydrogen is taken outside. Alpha and beta, in between them, there is a removal of water on the dehydration on heating. It gives C6H5CH double bond CH single bond CH. In aldol, there was crotonaldehyde, alpha beta unsaturated aliphatic aldehyde. Here it is alpha beta unsaturated aromatic aldehyde called cinnamaldehyde is formed. And this pattern of reaction is called Glycine reaction, also known as Glycine-Smith reaction. Very, very simple and very important reaction to be followed. In the same way, the benzaldehyde C6H5 C double bond OH benzaldehyde is treatable with acetone. It is the other example. In the case of acetone, it is a formula for acetone. For the convenience, two hydrogens are taken outside from the acetone. So try to get water in between them by using the same reagent called dilute NaOH. Then what happens? C6H5CH double bond CH C double bond OCH3. The highlighted group, underlined group is called as Benzoyl group. The highlighted part is called Benzoyl. Now the Benzoyl is getting attached with acetone, and hence the compound's name is benzoyl acetone. It is also called as benzylidene acetone. Benzoyl acetone, also known as benzylidene acetone. Its mechanism can be explained as follows. Yes, I can write the mechanism. C6H5 C double bond OH benzaldehyde plus acetone H CH2 C double bond O CH3 by using dilute NaOH. In the first step, this hydrogen is taken outside and electrons are moving towards this side, so that we can have CH2 C double bond O CH3. It carries minus, and that will be attacking this carbon, and the nearby bond is getting broken. So the product will be C6H5 CH double bond is converted into single bond, so that we can have O minus, and here I can write CH2C double bond O CH3. Now this is to be protonated by using water, adding of hydrogen plus to that oxygen. That results to the formation of a molecule as follows: C6H5 CH, it becomes OH, and one of the hydrogen is taken outside. Yes. Now this on dehydration, the H is removed and OH is leaving, and the product is written as follows: C6H5 CH double bond CH C double bond O CH3. I can write that product here. It's a product made. C6H5 CH double bond CH C double bond O CH3. The compound what is written here is called as benzoyl acetone. Okay, this group is called as benzoyl group. Here it is single bond. Benzoyl acetone is made, also known as benzylidene acetone. So in this way, the Glycine-Smith reaction can be explained, followed by Cannizzaro reaction. What is it? The Cannizzaro reaction. Cannizzaro reaction is also called as disproportionation reaction, also known as self-oxidation reduction reaction. Self-oxidation reduction reaction. The major contrast in between Aldol condensation and Cannizzaro reaction: for the Aldol condensation, there must be presence of alpha hydrogen. Here, for the Cannizzaro reaction, there should not be any alpha hydrogen. So the compounds without alpha hydrogen atom can undergo this reaction. These are the examples: C6H5CHO, benzaldehyde. It's not going to have alpha hydrogen, so it can answer for this. Formaldehyde, it is not containing alpha hydrogen, so it can undergo this reaction. So all your aldehydes, either it is aliphatic or aromatic, when there is no alpha hydrogen, they can undergo this self-oxidation reduction reaction, also known as Cannizzaro reaction. Yes, first I am writing the Cannizzaro reaction, and we can have explanation for that. It's a Cannizzaro reaction. C6H5CHO plus C6H5CHO. The reaction takes place in presence of diluted form of sodium hydroxide, which means 50% of NaOH, caustic soda. then one will be oxidized and other will be reduced. You know, when the aldehyde is oxidized, we will be having the corresponding acid, C6H5COOH. Its sodium salt is formed. Its name is sodium benzoate. And other will be reduced. When the reduction of an aldehyde, we can have a corresponding alcohol. The name of the alcohol is benzyl alcohol. So we are getting the mixture of benzyl alcohol and sodium benzoate by using this benzaldehyde, and this reaction is also known as disproposed acid reaction because the same molecule undergoes both oxidation and reduction. And its mechanism is explained as follows. The mechanism of this reaction is given as follows. This is the mechanism. Step 1. Take benzaldehyde. This is H5C double bond OH. In the first step, it must be treated with a base called hydroxide ion, and this is going to attack the carbon, nucleophilic attack, and the pi bond is breaking up. So the product is H5CH O minus, and here we were attached OH. So it is the first step. The second step, for understanding that, you rewrite this in the reactant side, C6H5 CHO minus and OH. Now that should be treated with the first molecule of benzaldehyde. Second molecule I am writing, C6H5C double bond OH, benzaldehyde. There are two reactions which are taking place simultaneously, or two changes which are taking place simultaneously. One, the pair of electron present on the carbon oxygen atom, this one is moving towards this side. So there will be double bond. Immediately this hydrogen is shifted to this particular carbon. Try to understand this mechanism. It's very, very simple. The oxygen is carrying minus, so there will be double bond in between them. Now this hydrogen is leaving and it is attacking this carbon atom. So it is called as proton transfer step, which means hydride ion is getting transferred. Why this is called so hydride? Hydrogen is usually leaving as H plus, but in this case, hydrogen is leaving with electron, so it is leaving as H minus. So you can call it as hydride ion transfer, H minus ion transfer. When the hydride ion is attacking this carbon, the nearby bond is breaking and oxygen can carry minus. So this is simultaneously happening. So the hydride is transferred. Execute these changes and find the product. You can write the product easily by using this message. Yes, this is what is happening here. After the execution of all these things, the product is written as follows: C6H5, it becomes double bond OH. Other one, C6H5CH, one other hydrogen is attacking and it is carrying minus. So the substance formed is called benzoic acid, and this is said to be the benz oxide ion. So two steps are so far explained. Now in the third step, Write the products in the reactant side. The products which are obtained above can be written in the reactant side. Benzoic acid and benzoxide ion. They can be mentioned here in the reactant side. C6H5 C double bond OOH plus C6H5 CHHO minus. The acid-base reaction, proton exchange. How the proton is exchanged. In this manner, it is explained. Double bond O, I can write here it is OH plus C6H5 CHHO minus. This proton is transferred to this oxygen. Oxygen is giving electron to this proton. So execute the change and find a result. This is the result. You can have C6H5 C double bond O minus, and other one is C6H5 CHHOH. This is an alcohol. The name of the alcohol is benzoyl alcohol, and it is a sodium salt of benzoic acid, so that we can call it as sodium benzoate. So in this way, the action can be explained how the products are formed by using this Cannizzaro reaction. Cannizzaro reaction is thus explained. C6H5 C double bond O minus C6H5 CHHOH. Benzyl alcohol and the sodium salt of benzoic acid. It is the formula for benzyl alcohol. Okay. I think you have followed what I am giving you here, the Cannizzaro reaction, which is called a simple Cannizzaro reaction, followed by the crossed Cannizzaro reaction. What is called crossed Cannizzaro? That crossed Cannizzaro reaction is explained as follows. Yes, we can take C6H5 CHO plus HCHO, the mixture of these two, the mixture of both formaldehyde and benzaldehyde. The benzaldehyde usually undergoes reduction. Formaldehyde, having the lower molecular weight, it can be oxidized so that we can have the sodium salt of formic acid called sodium formate. So when you're having the mixture of two different aldehydes, the aldehyde having lower molecular weight can be oxidized, and aldehyde having higher molecular weight can be reduced. And with this, we are finishing this crossed Cannizzaro reaction. And other things we will continue at other time.